It's FMT100 7.4. Yes, we're looking at bearing types. Now, this is the fun part. So this is where you get to see the full schmooze that we've got going on for the different types of bearings. So um, keep in mind now, bearings by their nature, they're trying to reduce friction. They're trying to support and keep aligned shafts, and they may be designed and or asked to also deal with various loads. So we're looking at radial, axial, or radial axial loads on our poor bearings. So please keep that in mind. But we'll just dive right into it. So we'll just go from here. So everybody's familiar with the traditional, once again, ball bearing. So we've got single roll ball bearings, which it's just a single roll of ball bearings. Wow, they really went on a limb on that one. Or double roll. It's two rolls of ball bearings right next to each other. Yeah, like I said, they really went out on a limb to name these. So these are all anti-friction. So that's the good news. And all these guys are trying to do is they're trying to reduce the amount of friction between the shaft and our housing, our mounting, so the shaft rolls a lot easier. That's what we're trying to do. And in case you're wondering, well, how do bearings do that? They reduce and distribute the forces through smaller surface area. Instead of having the entire shaft circumference touching the housing, we just have small fractions of that surface area touching, and that's the point that the roller element, in this case the ball bearing, is touching the outer ring and the inner ring. That small little area, because it's such a small area, it's less friction, so it's easier for the shaft to turn. That's all that's happening. I know, wow. You thought it was probably going to be more whatever than it was. Nope, that's it. So here's our bearing type. Once again, this is our ever glorious ball bearing. We've got an outer raceway. That's our outer ring here. So our outer race is inside our outer ring. We have an inner ring with an inner raceway. We've got our roller element, which happens to be in the shape of a ball. Therefore, it's a ball bearing. And we've got a retainer, a separator, and that's what this little bracket is around the bearing. And one of the things I'm hoping to do is at some point finally try and grab a different examples of all the different bearings, so I can actually have a real photo of them. But I have none at the moment, and you try and do an image search. It's been absolute hell, so that's why I don't have any. Anyway, on our raceways, check out, we've got a raised shoulder here. I'll get my cursor back. I'd love to be able to do the laser thingy here. Nope, not that one. It's not going to let me do the laser. Anyway, so here's our shoulder right where our arrows are pointing, and this allows this bearing to suck up on some radial axial loading. That's all the shoulders do. The shoulders also help keep our roller element in place. So it does both. So let's go to the next slide here. Now, they're saying this one is a thrust bearing. Yeah, no, yes, possibly, if you want to call it that. This is a special type of ball bearing. This is a plane bearing, or not a plane, but a plate bearing. Plate. Plate, plate bearing, because it looks like two plates that are stacked up on each other with a ring of ball bearings in between the two. So this is a special application bearing where, if you notice, we've got the load being applied is downward. It's axial. So the load is axial. And in case you're wondering what these kind of look like, if you ever saw a caster wheel, or even a spice wheel, where the wheel, you'll put your spices on and you spin it around. If you looked underneath the wheel, between the wheel and the base, you'll find one of these bearings there. These are nice. They do make spinning whatever it is really easy. The bad part is, if you apply the smallest amount of radial load or axial radial load on these things, the two plate surfaces, because you notice that it's not an inner or outer ring, it's just two plates. The two plates will separate, and then the ball bearings go shooting out. Major pain in the butt. And for those of you who may find yourself working in an office type building, the nice swivel chairs have this type of bearing, and as people go to the edge of their seat because the email is that exciting, you'll have them inadvertently separate the two plates on the backside of the chair, and the ball bearings go out, and then the chair doesn't work anymore. So that's what's going on with these. Good news is, once again, they are a specialty type bearing, and you don't see them in heavy industrial use that much. So you might see them in caster wheels, and that is about it as far as I've seen. On the other hand, we've got a self-aligning bearing. These you will see just about everywhere. So these are common. Once again, we're still looking at ball bearings, and they may also come in a funky cylinder, but they're using ball bearings in this case. And I have to point out, just like they are, notice the curved outer raceway. This outer raceway with the curve, it allows the slight misalignment between the outer ring and the inner ring. So our shaft, while it's mounted onto the bearing and the bearing is pressed into the housing, we can have a misalignment just a little bit, maybe a degree or two. But this bearing is designed so it will take that into account. And what's nice is it will keep working normally within that small swing. So if you go past that, past the allowable deflection, then the ball bearing will start having issues. It'll bind up. But if you stay within the prescribed deflection or misalignment, however else they want to describe it, this bearing will continue to operate just hunky-dory with little or no problems, which is ideally what we want. And once again, it's all to do with the outer curve in the outer raceway. Or I'm sorry, the curve in the outer raceway. So that is where the magic is made with this type of bearing. And this is a common one, so keep that in mind. Cylinder roller bearings. Yeah, the rolling element's in the shape of a cylinder. Yeah, I know. Wow, it kind of follows the name. Yeah, go figure, right? So we're allowing more surface contact. As we increase the surface contact, we increase the load capability of the bearing. Now, earlier I'd said, if you are looking at anti-friction, where you're trying to make things move really, really easy, ball bearing is a way to go, because the ball bearing is a very small point of contact between the outer ring, the ball bearing itself, and then the inner ring. So because you've just got that small point of contact on the surface of the sphere, we have really easy movement with the shaft. You can spin the shaft really easy, fingertips. But because it's such a small contact area, not a lot of load can be handled by those ball bearings. If you need more load, if you're going to put more pressure on the bearing, you're going to need a bearing that can withstand that pressure. And a cylinder has more surface area because you're stretching out that ball and make it into a cylinder. So now you're increasing the surface area. So with that, you can increase the load. You're taking whatever force is being applied and you're spreading it out. So if you're spreading it out over a wider area, you can apply more load for the amount of pressure you have. Anyway, I know, physics, go figure. So that's the good news there. Because you increase the surface area of contact, these are a little harder to spin, but you can still spin them. Instead of using fingertips, you're probably just going to have to use your full finger, your full hand, and just give it a twist, and away we go. So they put in the nice little caveat here. Golly gee willikers, yes, we're looking at radial loads primarily, although they can get into some radial axial, depending. But yeah, I'll go with the more of the radial loads. So we're looking at regular just spinning. Spherical, that's our self-aligning bearing. It looks like a squashed ball bearing. I can't call it a cylinder because it doesn't look like someone's taken round stock and just cut little pellets out. It looks like someone squished a ball bearing. Your spherical rollers are, and away we go. Another one that's considered heavy duty is because you're dispersing the amount of force over a larger area. So that's the good news there. And then here's my babies. And yeah, if you ask me what type of bearing I have for a favorite, it's going to be this one. It's called the taper roller bearing. And taper roller bearings are used when you have a lot of thrust. And thrust tends to be an axial load that is huge. So a roller bearing will take axial loads and prevent that axial load from being transmitted through the shaft. You'll still have the shaft under the axial load, but the roller bearing is taking the brunt of it. So that's the happiness for taper roller bearings or thrust bearings. And you'll see these if you have a vertical shaft, and that vertical shaft is holding up but still allowing something to rotate that's very, very heavy, you'll have a taper roller bearing at the bottom of that shaft. Hopefully it's at the bottom. If not, that means it's that load is being supported from the top, and guarantee you're still going to have a taper roller bearing at the top, which is a major pain. But once again, this is an axial deal, so you may even have a plate bearing. But that is extremely rare, especially for the type of loads that taper bearings can handle. So, like I said, 9 times out of 10, heavy load that you're trying to support vertically, you're going to be a taper. If you've got a load that is really heavy on a horizontal shaft, and that's trying to push that shaft in either direction, and you're going to love me for this one, pumps. Liquid pumps. Liquid pumps is if it is a centrifugal pump will create and induce a large thrust. And you will want a taper bearing that can withstand that. especially if that pump has only one inlet. If it is a dual inlet and you've got an inlet on either side of the impeller, then the thrust goes to 0, and then you can just do regular anti-friction bearings. If you have a large centrifugal pump with one central inlet, the poor little bearing that is on the other side of the impeller going towards the motor, you are going to want a thrust bearing, so your motor does not have to deal with the thrust. So just so you know, there, it's out there. All right. So taper bearing, needle bearing is kind of a subset of it. And needle bearing, instead of coming just to a regular taper, the needle bearing almost comes to a point, and there tends to be a lot of them. So, and yeah, they're long and thin. They're easy to lose. Just letting you know now. If you've got a bearing that blows out and you're trying to find all the pieces, depending on the process, you may need to account for all of them. Yeah, the needle bearings can be a pain. And because they're so small, you also need to take great care in installing them. All right. And if you're going to be able to reuse the bearing, and you're doing a teardown, you also need to take great care in removing them as well. But definitely for sure, utmost care on installation so you don't damage these. And then there's plain bearings, or as I like to call them, bushings. So plain bearing is nothing more than a sleeve, and it may support either axial or radial loads. And it could either be a sleeve that, as it's saying here, solid, so it's goes completely around, split, so it's cut in half, and then you put the two halves together. Half bearing, you only get like the half. Either goes on the bottom or the top. Typically goes on the bottom. Or a thrust bearing. And the thrust bearing is odd because what you're actually looking at is it looks like washers now. And you would put the plain bearing, the thrust bearing, against the housing, and then your shaft with its rim would go against that thrust bearing. So plain bearings are made off a softer material than the housing and the shaft. The soft material tends to wear out, so we need to make sure that these bearings are always properly lubricated. They're usually lubricated with oil, and the oil helps coat both pieces, the bearing as well as the shaft, and any of the shaft members that happen to be pressing against the bearing. And engineers like to say that in this type of arrangement, the two pieces of metal never really touch because there's always a thin film that's formed as the shaft is rotating. And ideally, yes, that's true, unless you don't have proper lubrication in the sense of you don't have enough, you're using the incorrect type of lubrication, or the bearing area overheats. And when that happens, then the lubrication, no matter what it is, typically doesn't work as well as it should. And it can even, quote, burn off. So now you're just exposing two metals, and the two metals are allowed to rub directly to each other, which is a bad juju. Terrible, terrible things happen when that happens. You basically think of trying to start fire, rubbing two sticks together, and instead of doing sticks, use metal. And yes, you can start a fire rubbing two metal pieces together. That fire's hot, and it sucks because it destroys the equipment. That it can be done. So the bearing material is affectionately known as a babbitt, and it usually has a lead component to it, or oh, good gravy. They're trying to do it. I had the name of like cadmium or something like that. Is the other? It's a soft. You're looking at soft metals. So even brass and copper will be used, as well as aluminum. So all those things are going to be in your text as well. All right. So this is kind of what they look like. So we got the regular solid bearing. This is known as a sleeve. So the solid bearing is known as a sleeve. There's my cursor again. Hopefully you guys can see that. Here's the other. This is a half bearing. So once again, the shaft is going to ride on this. It's going to ride because all the forces are downwards. This is a radial load. So it's just going straight down. So we'll have the bearing at the bottom, and we'll allow the shaft to rotate there. This is our split bearing, and it's like the solid bearing, except it's been split in half, so you can have a bottom half and a top half. Depending on the bearing, you will also see on the split bearing holes where lubrication oil is supposed to be allowed to circulate through the bearing. So the lubrication oil goes through the bearing and then goes to the shaft. And then the shaft is able to carry away that lube oil and spread it to the inside. And then here's our thrust bearings, or our thrust washers. And once again, it's still going to be made out of a soft metal. And we are going to allow these to be nice and smooth. And if they have any wear, we'll let our bearings wear away instead of our housing or our shaft. But in order to prevent that, what we're really looking at is golly gee willikers, proper lubrication. And yes, lubrication is so intense that we even have a unit dedicated just to it. But before we can get there, we've got to finish up with bearing installations and failures, as well as getting through anything else between us and that unit. So let's just keep going on here.